Welcome to this explainer. Look, if you build web apps, you already know that performance is basically the holy grail. We are constantly on the hunt for ways to make our user interfaces faster, leaner, and more responsive. Every single millisecond counts, and let's face it, user expectations have literally never been higher. So today we're diving into a library that is aggressively challenging the status quo and making some massive waves in the developer community. We're talking about SolidJS.
For years, the virtual DOM has been our go-to solution, right? It's the engine driving the biggest frameworks in the world. But let's be honest for a second. As our applications get more and more complex, we're increasingly having to ask ourselves a pretty tough question. Is it actually slowing us down? Because all that diffing and patching creates computational overhead, and that overhead can become a real bottleneck when you're chasing lightning-fast rendering times for fluid, complex applications.
So here's our roadmap for today. We'll start with the quest for performance, then look at what it actually means to ditch the virtual DOM. After that, we'll dive inside fine-grained reactivity, see how to build with modern components, and finally wrap up with why developers choose SolidJS.
All right, let's kick things off with Section 1, the quest for performance.
Now, naturally, when developers get fed up with sluggish rendering, they go hunting for a better way, and this specific name just keeps coming up. So what exactly is SolidJS, and why is this particular library suddenly the topic of so many engineering conversations?
Basically, SolidJS is a modern declarative JavaScript library built entirely around efficiency. But what really makes it so compelling is that it feels incredibly familiar. Like, if you know React or Vue, you'll immediately recognize the component-based architecture. You'll see concepts that look exactly like hooks. You aren't learning some strange new paradigm from scratch. But here's the catch. Beneath that comfortable surface, the underlying engine driving those components is completely different. It gives you the developer experience you already know and love, but paired with a performance profile that is entirely new.
Which brings us nicely to Section 2, ditching the virtual DOM. Since it looks and feels so familiar on the surface, it brings up the obvious question. How does SolidJS actually differ from a giant like React? Well, the answer lies entirely in that underlying architecture. It is all about how the system decides what to update on the screen.
Okay, think of the traditional virtual DOM, like trying to fix a single typo in a massive 500-page manuscript. Every time there's a tiny change in your app state, the virtual DOM forces the system to scan the entire new version of the manuscript, comparing it word for word against the old version, that's the diffing process, just to locate and patch that one single typo. It works, sure, and it revolutionized web development years ago, but it has serious overhead. As your app grows, that manuscript gets longer, your component trees get deeper, and the diffing gets significantly heavier. Well, SolidJS literally throws that manuscript out the window. By using direct DOM manipulation, it completely skips the diffing process. When you compile your code, SolidJS figures out exactly how your data connects to your UI, so at runtime, it instantly knows exactly which word on which specific page needs to be erased and rewritten. No scanning, no comparing, no overhead. Just precise, instant updates directly to the browser's document object model. This fundamental shift is the real secret sauce that unlocks that next-level speed.
Let's zoom in a bit for Section 3, inside fine-grained reactivity.
So how exactly does it instantly know where that typo is? It all comes down to a concept called fine-grained reactivity. SolidJS tracks dependencies at a highly granular, almost microscopic level. It maps out exactly which parts of your user interface rely on which specific pieces of data. When a single piece of data changes, the system doesn't just broadly re-render the whole component. No, it simply reaches in and updates the tiny UI element connected to it. And let me tell you, this predictable performance translates directly to a buttery smooth experience for the end user.
It all starts with signals. You can think of a signal as your basic building block, a single atomic piece of reactive state. To make this practical, imagine you're building a user profile page, right? And you have a field for the user's first name. That first name is a signal. You can read its current value, and you can update it when the user types something new. But crucially, because it's a signal, SolidJS is actively watching it. The split second that first name changes, SolidJS immediately notifies any other part of the application that cares about it. It is the absolute bedrock of this entire reactive system. Next up, we have computations. These are essentially functions that take your signals and use them to create new derived values. Let's keep going with our user profile example. If your primary signals are first name and last name, your computation might be a function that takes both of those and generates a full name. What makes computations incredibly powerful is that they automatically track the specific signals they rely on. You don't have to wire anything up manually. The computation knows it needs first name and last name, and it will only rerun exactly when one of those underlying signals changes. If the user updates their profile picture instead, this computation does absolutely nothing. It perfectly isolates your logic and prevents any wasted effort.
And finally, we have effects. An effect is basically a special kind of computation that actually reaches out and touches the DOM, the physical elements the user is actually interacting with on the screen. So let's tie this entire pipeline together. The user updates their first name signal by typing in a text box. The full name computation we just talked about is automatically notified and instantly recalculates the new combined string. Then, the effect catches that updated computation and directly reaches into the DOM to change the specific text node displaying the user's name. That's the complete cycle, signal to computation to effect. Boom! There is no virtual DOM diffing required anywhere in that entire chain, no reconciling complex component trees, just a direct, frictionless pipeline from the data change straight to the pixels on the user's screen. This architecture entirely eliminates the need for bulky boilerplate code and keeps your application logic incredibly clean.
Moving right along to Section 4, Building with Modern Components.
Now, it's totally fair to look at these microscopic, granular updates and ask the tough enterprise question. Is SolidJS actually robust enough for a complex, large-scale application? Or is this just some lightweight tool meant for simple side projects? Well, the short answer is absolutely yes. It is highly scalable, and the architecture actively encourages best practices for large code bases. It achieves this scale by giving developers a rock-solid, familiar toolkit. First off, you build with modular, reusable components. Just like in other major frameworks, you encapsulate your UI and behavior into clean, independent building blocks, which keeps your code organized and highly maintainable even as the project grows to hundreds of files. Second, because of that fine-grained reactivity we just explored, you manage state locally with signals. Think about how in many complex React apps, you often have to pull in heavy external state management libraries just to avoid unnecessary re-renders across your app. With SolidJS, the built-in reactivity handles the data flows so efficiently that those massive global state stores are often entirely unnecessary. And third, you are building natively with modern JavaScript. SolidJS fully embraces ES6 modules, async await, and modern syntax right out of the box. You aren't fighting the language or dealing with bizarre custom templating rules, you're simply writing clean JavaScript. This makes onboarding new team members so much faster and keeps your enterprise applications strictly aligned with modern web standards.
Let's wrap things up with Section 5, Why Developers Choose SolidJS.
When you distill the whole shebang down, the overarching benefits driving this massive developer adoption become super clear. First, you get unmatched performance by completely dropping the virtual DOM in favor of direct, granular updates. Second, you get simplicity. You're relying on an intuitive API that gets teams up to speed fast without retraining them from scratch. Third, you have incredible flexibility. You can build everything from a simple single-page marketing site all the way up to a massive, data-heavy enterprise dashboard. And finally, you have the backing of a rapidly growing ecosystem that is churning out a wealth of resources, robust routing solutions, and highly capable server-side rendering tools.
Ultimately, SolidJS is proving that we can absolutely achieve exceptional speed and predictable performance with direct DOM manipulation and fine-grained reactivity. And it really leaves us with a provocative question. As these new paradigms emerge and consistently top the performance charts, is the virtual DOM finally becoming obsolete? It certainly challenges us to rethink our default framework choices before we sit down to build our next high-performance web app. Thank you so much for joining me for this explainer. I hope you found it insightful.